Okay, so welcome back. So now, in this video, I want to talk about work rate problems where it involves more than one person, right? In the last example, it was an example of one carpenter installing a door at a certain rate, and we wanted to know how many doors he could install in 40 hours, right? And his rate was 1/3 of a door per hour, and so it used the formula of work done equals the rate of the work, right? So the rate at which the person works or the machine works times the amount of time that they're working, right? And we found that he could install 14 doors in 40 hours, right? So now in this video I want to introduce, well, what about if we have multiple people or machines working, right? What if we were combining, let's say 2 people are doing the job, right? Or 2 machines are doing the job. Then how do we work out how long it would take to do the job if in that situation, okay? So instead of having one person or machine doing it, we have 2. So these are the steps I'm going to go over on how we handle those things. So the first thing is we want to find the individual rates of work, okay? So once we know the individual rates of work, then we want to identify the amount of time each worked, okay? So we want the individual rates of work and the time that each person worked or each machine worked. Then we're going to use the formula for completing one job, okay? And that formula is this. So we're going to take the amount of work done by the first person or machine plus the amount of work done by the second person or machine. And if we add those 2 amounts up, they should add up to one completed job, right? Or one completed task. Whatever the case may be, painting a house, building a fence, whatever the case may be, okay? So now also what this translates into, remember using the individual formulas, this is going to be the amount of work done by the first person, right? Plus the amount of work done by the second person. That's really what it comes down to. So in this case here, we can use our work formula, our work rate. So this translates into, well, the rate of the first person times the amount of time the first person or machine is working, plus the rate of the second person or machine times the time of the second person or machine is equal to 1. Okay? So that's the formula that we're going to use. And so let's look at some examples and see how this works out.